Okay, so this is the solution for the problem set, for the long exam set B. Now, the problem reads that you have a 10-gram marble slide, which slides to the left with a velocity of magnitude VAI on the frictionless horizontal surface on an icy New York sideway, and has a head-on collision with a larger mass sliding to the right with a velocity of VVI. So this part here you have to sketch so that you can have a clear idea of what you are going to solve, as well as the sign of the specific velocities. Now I will label this as before collision, and then the very first marble that is being discussed or that is stated in the problem is your 10 grams. So I am going to denote that as my marble A. So I'm going to write also here MA is equal to 10 grams. And then it moves to the left. So that means to say it's moving towards this direction with a velocity of, it's actually an unknown velocity, VAI. And then also it has a, as you can see here, head-on collision, but the collision is elastic with a larger mass. I'm going to draw a larger mass here. That is 30 kilograms, so maybe like that. And I'm going to call this mass B. And the larger mass B slides to the right. So that means to say that I am going to put an arrow towards the right with a velocity of magnitude VB sub I. Okay, so that is the case before collision. Now, over here, it says here that you need to find the initial velocity of each of these marble. It means to say you have to solve for VAI as well as VBI before the collision if, so this is now a very special case or a nice problem in the sense that this is what I'm talking about in class na. There are cases that the sketch would be very helpful if na after collision a sketch, which is this problem. Now it's very clear here that after the collision, the 10-gram marble, so this one over here, the sizes are not really the same as above, but I'm just going to label it as A, and the other one is B. Okay, this one is B. After the collision, the 10-gram marble moves to the right, so that means to say it's now moving towards the right with a speed of 0 or a velocity of 0.5 meters per second. So I'm going to label that one as my V A sub F, which is 0.5 meters per second. And also it's stated here that a 30-gram marble moves to the left at 0.100 meters per second. So it has this arrow towards the left, and that is its VBF. Since it's moving towards the left, it must rightfully be given the appropriate sign of negative 0.100 meters per second. Take note that you are dealing with velocity, which is a vector quantity, so the sign should be always taken into consideration. Now, to answer this question, so that we will be guided with the problem solving, the type of collision, the same with the set A. Actually, you are dealing with the same problems, only different lang na given. The type of collision is very clear and stated in the problem that the collision is elastic. So that means to say that the conserved quantities for this are our momentum, which again is always conserved regardless of collision, and its kinetic energy. So this is also telling us that we can utilize two equations in this case. One from momentum, equation coming from momentum or conservation of momentum, and the other one will be coming from the conservation of kinetic energy. So let's start from the conservation of momentum. From the conservation of momentum, just write P. Okay, the conservation of momentum says that the total momentum before collision must be equal to the total momentum after collision. And that means to say that that is just the momentum of A initial and the momentum of B initial must be equal to the momentum of A final plus the momentum of B final. So we knew that momentum is just mv, so I'm going to break this down into its component. That's ma vai, that's for pai, momentum ai, plus mb vbi, this is for the second term, which is pbi, is equal to m sub a vaf plus m sub b vpf. Okay, now if you try to inspect each of these variables, you notice that MA is actually given, VAI is something that you don't know. This is an unknown. MB over here is given. VBI is also something that is unknown. MA is given, VAF is given, MB is given, so is VBF also. Now you are realizing that you are actually dealing with one equation, we call this equation 1, with two unknowns. So I'm just going to put a notation here that um, color here represents that an unknown, that is an unknown. And again, in algebra, especially when we are dealing with systems of equation, finding the values of a variable, if you have two unknowns, you need at least, this is the minimum, at least two equations. So that means to say we are still going to create another equation to solve this one. And that equation will be coming from the kinetic energy. So I'm going to write here, from the conservation of kinetic energy, Ke, that means to say, let's utilize the shortcut where we deal with velocity. So I would like again that you listen on this part because this is where most of you got it wrong. The velocity of ball A, that means the one mass before collision, we'll really put heavy emphasis on this one, plus, not plus, it should be and after collision. That means to say the right hand side deals with both before and after collision, is equal to the velocity now of the other mass, in this case B, both before collision and after collision. So that means to say that the equation would look like this. The velocity of A initial, that means before collision, plus the velocity of A final, that means after collision, must just be equal to the velocity of B before collision, so that's I initial, plus the velocity of B after collision or final. So from there, I'm going to express VBI in terms of the other variables. So that means to say I have VAI plus my VAF. Since VBF, this term will be transposed to the other side, it will have a negative sign, minus VVF is equal to VBI. So this one over here is my second equation. We'll name this equation 2. Alright, so we now have two unknowns and at least two equations, so we are sure to be able to solve this one. So what we are going to do, I'm just going to erase some parts here because it's annoying me. Okay, and put it in a box. Okay, what I'm going to do is to substitute, we're going to substitute equation 2 into equation 1. So when we do that, we will have MA VAI plus mass B VBI is equal to MA VAF plus mass of B VBF. Alright, so if you look over here, this VBI is equal to this one. So I can just simply substitute all of these things or variables over here over this VBI. So when I do that, I will have MA VAI plus, you need to be very careful with the subscript as well as the signs. So MV, now VVI is just, sorry, I should have set that into do not disturb. VBI is just VAI plus VAF minus velocity of B final is equal to MA VAF plus MB VBF. Okay, so I'm hoping you are able to follow that line of equation or line of um, substitution that we did. And the next thing is you need to multiply MB or distribute MB to each of these terms over here. So when you do that, that is quite easy. You just have to be very careful in the notation. VAI plus MB, this one will become VAI plus M sub B VAF minus M sub B VBF. And everything is equal to MA VAF plus massa BMB VBF. Okay, so let's do again an initial inspection of whether we are now having one equation with one unknown only. So MA is given, VAI is an unknown, you don't know this one. MB is also given, VEI is, as I've said, unknown, so but that two things mean the same, so it's only one unknown. VMB, VAF given, given, VBF given, this is a given, VAF given, MB given. Alright, so this is a very good news because we are now dealing with only one unknown. Alright, so the next thing that you need to do is you have to isolate the unknown, which means you isolate VAI. So to do that, that must be found on only one side of the equation. So dapat naalang ni sila diri VAI plus M sub B VA sub I. So what I'm going to do with these two terms over here is I'm going to transfer that to the other or transpose that to the other. I'm just going to erase this because again it's annoying me. Okay. Okay. So when we do that, I'm going to copy first this term. So that's MA VAF plus massa B VBF. So I'm going to transpose this first, so that will become minus M sub B VAF, and this one, it will become plus MB VBF. So the next thing is so that the solution will be clearer and you will more like get rid of the chances na masayop mog substitute. It is always advisable that you group together those which are similar terms. So what I'm trying to say is you group together all those which has VAF. So VAF, this is VAF, and this one over here has a VBF. This is also VBF. So you factor out the common terms, or before that, maybe I will just show that rewrite so that they are together. Forgot to put some arrows. VAF minus MB VAF. So I just rewrite the equation where those with similar terms are together or close. VVF plus MB VBF. Now, needless to say, on the other side of the equation, you notice that your VAI is a common factor, so you're going to factor that out. That means to say you have VAI, and then that will just be MA plus M sub B. Okay, so VAI, just going to rewrite this, MA plus MB. When you try to inspect the right hand side of the equation, that means this portion over here, you can actually isolate or factor out VAF. That means to say you can now have MA minus MB. Now over here, VBF is also a common term, so you have to take that out or factor that out. What is left now is MB plus MB. Alright? So the next thing that you're going to do is to multiply both sides of the equation by MA plus MB plus MB. You do the same thing on the right hand side of the equation to preserve the equality. And then this one would cancel out. So you have VAI is just equal to this one over here. So I'm just going to copy that one. Copy and paste. Okay. So from here, you're just going to substitute the values. So VAF, if you go back to the problem, is 0.5 meters per second. So that's 0.5 meters per second. Your mass A, this is the smaller mass, that's 10 grams. Mass B is the larger one, that is 30 grams. Plus VBF. If you notice in the problem again, VBF is given that is going to the left, so that should be negative um, 0.100. So negative 0.100 meters per second. So MB plus MB, that is just 30 grams plus 30 grams. And everything is divided by the sum of the masses. That means to say 10 grams plus 30 grams. So when you calculate this one on your calculator, just make sure to group well. I say group well, you have used proper grouping symbols. Kaya kasi if you look at this one, this product, this term over here must be multiplied with this one, and then you add it with the product of this one. So sometimes masayop lang mo pag-calculate. So magbantay yun mo ana. So when you try to plug that values in your calculator, that will give you a value of negative 0.1 with a unit of meters per second. So that means to say that over going back to your problem, your VAI daw has a negative value. And so ganito pasabot, when you have a negative value that is moving towards the left, when you have a positive value that is moving towards the right. And sure enough, this is sensible. Why this is sensible? Because from your sketch, it's stated in the problem that the 10-gram marble, which is your mass A, this one over here, moves with to the left. So that means to say that it is being confirmed that, okay, we are getting the correct answer because of the negative sign. This indicates that indeed your VAI or marble A moves towards the left. Okay, so this is just the tedious part. The rest is very easy because if you try to solve for VBI, that means to say how fast is ball B moving, you are just going to use the equation 2 above that one. So that is just VAF plus VBF. VAI, sorry. It's VAI plus VAF, VAI plus VAF, and then minus VBF, minus VB sub F. So we already solved for VAI, so that's negative 0.1 meter per second. Now take note class, whenever you did an incorrect calculation of VAI before, syempre your VBI will be affected as well. So you need to be very careful in your calculation. Okay, so continuing the VAF, going back to the problem, is actually moving towards the right at 0.5. So I'm just going to substitute 0.5 over here. Now minus VBF. Your BVF is moving towards the left. So that will be minus negative 0.100 meters per second. So when you try to work with this one will be distributed. So that's just positive 1, or positive 100, positive 1, negative 1. So positive, this one here is positive 0.100 or 0.10. And then you add it with negative 0.10. So they will just cancel out. So it's clear, very much clear, that the answer would be positive 0.5 meters per second. So this is your VBI. That means to say that initially before collision, your VBI must have been moving towards the right. Okay, now let's try to check if this is making sense. Okay, your VBI over here, based from the problem, your VBI is the 30 grams marble. It's sliding towards the right. So this is again a confirmation that we are actually getting the correct answer kasi the sign matches. Plus indicates towards the right, and VAI, the 10 grams, is actually moving towards the left according to the problem. Okay, so this is the solution for the long quiz set B.